Who won the election? Oh, sorry. Hello, everybody. This is lesson 20 in Math 100. The theory of voting is the topic for lesson 20, and my background is, of course, the Capitol building in Washington, D.C. I picked up this, and it just so happened that there is some sort of a dark cloud covering one of the most iconic buildings in Washington, D.C., and which sort of represents the whole ideology of democracy, right? We'll see what happens. Now, today, this is the theory of voting. So we'll talk about different methods of declaring the winner. Now, this is very different from what we practice, but theoretically, there are different ways of deciding who wins an election. And it doesn't have to be a political election. So, I mean, as mundane or as simple as it may be, let's say your group or your group of people, or maybe your class, or somebody's deciding on a certain activity or vacation destination or whatever, right? And then you can decide to take a vote. And depending on what method you choose, that could result in different outcomes. So that's the kind of thing we'll be looking at today. It doesn't have to be political. The mathematical structure is the same, and the theory of voting is applied in many different decision-making processes. So let's do that. Let's do lesson 20. Okay, so lesson number 20 is on the theory of voting. The main question is who wins an election? All right, so you have a ballot box. Now, you may think this is simple. I mean, whoever gets the most votes wins, okay? And that happens to be one method of declaring the winner, okay? So, and this is pretty much traditionally what happens in our society, right? Not always, because in your workplace or in your organization, maybe you decide to use another method of voting. And we'll talk about like 4 or 5 different ways of deciding who wins an election. But typically you have this ballot, and you put one name or one choice or one option, whatever it is, and then you cast your ballot, and then you count whoever counts and see who wins. That happens to be called the plurality method. All right, that's the first one we will study. But before we get into this, let's look at what really happens in the mind of these people who are voting. Okay, so here is the first thing to know. Who wins an election? And again, this could be a political office, or maybe it's in the context of sport. Maybe they're choosing the MVP, the most valuable player in the sport. Maybe people are voting for a favorite restaurant. Maybe they're voting for the best restaurant in the town or something, right? Or how about a policy? How about deciding on the academic calendar in a community college, right? So there are all kinds of things that people decide by voting, right? And we will use what we call a ranking table first to see what's going on in the mind of those who are casting ballots, okay? And this kind of a table is called a preference schedule, all right? So we are ranking the candidates called A, B, C, D, and E, okay? So let's suppose we have 5 candidates or 5 possible options, maybe 5 vacation destinations or 5 activities to do or 5 kind of restaurants to go to, right? So these 5 don't have to be people. In this particular example, I'm going to consider A, B, C, D, and E to be political candidates, all right? So we think of, these 5 people. And people have preferences, right? So let's say 18 people, and these are the people who are going to eventually vote. 18 people would prefer to cast their ballot for A. But if they have to rank all of these political candidates, 18 people rank them in this order, A, D, E, C, B, okay? 12 of those people think B is the best candidate, but they will order them in this order, B, E, D, C, A, and so on, okay? 10 people have the ranking C, B, E, D, and A, right? So you notice here, for instance, you can tell right away that A is a candidate that is very divisive, right? 18 people think that A is the best candidate. Everybody else seems to think A is the worst candidate. Don't start thinking of, certain particular people. I am not being political. I am just trying to teach you some mathematics, okay? But you can almost see personalities in here, right? So A is that kind of candidate. B C, D, and E, have different personalities, perhaps. Okay. By the way, how many possible rankings are there? Okay, so you have 5 candidates, and basically you are going to list them in a particular order, right? So the ordering is important, of course, and you cannot rank the same person for first and second and third. So the repetition is not allowed, and you're trying to line up or to list 5 candidates in candidates in some specific order. The answer is 5 times 4 times 3 times 2 times 1. That's 5 factorial. And what I'm saying is there are 120 different ways to rank candidates if you have 5 candidates. That's a lot of ways, right? And right now you have 1, 2, 3, 4, 5, 6. There 6 out of 120 possible rankings are represented in this preference schedule. Okay, so this whole table is called the preference schedule, and you will see this is the fundamental thing when we decide on who the voters are going to choose. Okay, in every election method we study, the preferential schedule is what we will start with. Okay, now let's answer some of the questions by looking at this preferential schedule. This is a very good problem. I don't have to teach you how to do that. How many people voted here? If you have these people who ranked the 5 candidates casting ballots, how many people are considered altogether? Well, that's easy, right? All you have to do is to add up these numbers that you see on the top. 18 plus 12 plus 10 plus 9 plus 4 plus 2, and you will get 55 people. So there are 55 people casting ballots or deciding who the winner is. By the way, one of the important, and again, this is not a very sophisticated thing, but I mean, this is not a very difficult thing, but if you have 55 people, and you would assume that if one of the candidates gets a majority of these, ballots, then that person should be declared a winner, right? So what is the majority? A majority is a number that is bigger than half, right? So if you have 55 divided by 2, okay, this turns out to be 27.5. So 27 people would not be a majority, but 28 is, because 28 is bigger than the average of the 55 divided by 2, okay? So therefore 28 is a majority in this case. And that's kind of important, all right? Well, just remember this, take a note of this, okay? 28 in this case is going to form a majority, all right? What do you notice about A? I have already mentioned A is the favorite by 18 people and despised by everybody else, despised by all else. Okay, very divisive. That's one thing you can say about A. Who wins if all the voters can just vote for one candidate? This is my first question, okay? Now let's say, and this is the traditional way of voting, okay? In a typical way of voting, what you will do as one of the 55 people is to write the name of your favorite candidate, or just check, put the check on the favorite candidate. Now you may be one of these 18 people, and you think A is great. You may think D is pretty good. E, C, and B, not so good. Now you may be okay with A or D, but if you are to choose one person to write the name of, you would do A, right? So that's the kind of thing I'm talking about. So the question here is, who wins if all the voters can just vote for and write the name of one candidate, which of course is the first rate or first ranked candidates, right? So the method number 1, okay, the method number 1 is the one that we practice the most. It's called the plurality method. In the plurality method, the candidate with the most number of first place votes wins. Very simple, okay? Just assume that everybody is going to just write the name of one person, the most favored person, and whoever, the candidate with the most number of first place votes is going to win. No problem, right? This is the most typically practiced method of voting. This is the most common method. It virtually ignores all but the first row, right? So the first row, this is the first row, is the only row that matters in this method of election. You get that? All right, so should we give the answer here? Well, I think it's pretty obvious, right? A gets 18. B gets 12 first place votes. C gets 10 first place votes. D gets 9 first place votes. Now what E actually gets these two columns, right? So you have to add D. So for E, you do 4 plus 2, and that's 6. Okay. Now again, E has two columns here, but the sum of 4 and 2 is still 6. So E is, has the least number of first place votes. And guess what? A has 18, and this is the largest number of first place votes. And under the plurality method, A wins. Let's keep a track of this, right? So here's the little bubble. A wins under the plurality method, even though A is despised by everybody else except for those 18 people, right? Under the plurality method, A is going to be the clear winner of this election. No problem here, right? All right, so now I'm going to ask you the second question. How many people prefer A or E over A? Okay, so you see what the problem is here? If you're looking at this, right? If you're looking at E over A, so the question is, in which columns is E ahead of A? All right, well, in the first column, so here, maybe I should erase some of these things here to clean up so we can start thinking ahead. Okay, so when you are to answer this question, how many people prefer E over A? You look at this column here. Well, these 18 people clearly prefer A over E, right? All right, so 18 prefer A over E. How about E over A? Well, these 12 people think E over A. These 10 people think E is better than A. And so because A is at the bottom of every other column except the first one, all of these people would prefer E to A, okay? So, and that's how many people is that? It's 37. That's the sum of all of these numbers, okay? Or you can do 55 minus 18. That's 37 people prefer E over A, okay? Did you get that? All right, how many people prefer E over B? So now the question is, we're looking at this candidate E. Let's mark E. Let's circle every time you see E in this preference schedule. And so E is a pretty popular candidate after all, right? So how many of these people would prefer E over B? Okay, well, E is over B here. So we would mark this column here, E is over B. E is not over B here because these 12 people prefer B over E. But, and how about these people, B over E, but these 9 people prefer E over B. And then these 4 and 2 people prefer E over everybody else, right? So the answer to this question is 18 plus 9 plus 4 plus 2, and that is 33. Okay, that is definitely a majority. So the majority of the people prefer E over B. And of course, a large majority of the people prefer E over A. So E is actually a well-liked candidate. More people think E is better than A, and more people think E is over B, right? How about E over C? Okay, let's erase all the markings and count again. All right, if you compare E to C, all right, so these people prefer E over C, and these people think of E better than C. Here, these 10 people think C is still better than E. 9 people think C is better than E. 4 people think that E is better than anybody else, including C, and E is over C in this last column. All right, so the answer to this question, how many people prefer E? over C? The answer is 18 plus 12 plus 4 plus 2, and that is 36 people. Again, a large majority of people would prefer E over C, okay? And finally, let's compare E to D. So far, E beats everybody, right? E beats A, B, and C. How about E against D? Well, so these people think D is better than E, but this group, 12 people think E is better than D. And here, E is still better than D, that's 10 people. And here, D is the top, so that doesn't count. Okay, you see which ones I'm circling or putting in the box? If a column puts E above D, I am putting a square on around that number. E is over D, so it's square around this number. So a total of 12 plus 10 plus 4 plus 2, and that is 28 people. That is a small number compared to the other ones, but it's still a majority. Okay, so you know what this is saying? E is preferred over A, B, C, and D by a majority of the voters. So if you do a pairwise comparison, E beats everybody, okay? And this is the second method. So maybe I should highlight this. The first one is called plurality method. The second is, this is political science, you know, during the French Revolution, people studied democracy. And so many of these political scientists who have come up with these methods of voting have been French. And Condorcet, not Condorcet, but Condorcet is also a Frenchman, and he came up with this method of a pairwise comparison. And this method is called the Condorcet method, or otherwise known as the pairwise method. And this is how this method declares the winner. If one candidate is preferred over everyone else, and of course, there has to be, you know, only one if there is such a winner, because this person wins over everybody else. If one candidate is preferred over everyone else in one-to-one comparison, a one-on-one match, then that candidate wins, and he or she, the winner, is called the Condorcet winner. All right, so according to the Condorcet method, guess what? E wins this election. Now, I didn't change the preference schedule, right? I'm just saying, according to this preference schedule, if this is how these 55 people think about the candidates, under the plurality method, A would become the winner. But under the Condorcet method, E would be declared the winner, okay? And so that's why the winner depends on which method of voting or election that you decide to use. Having said that, Condorcet is probably not the best method to use, because sometimes you don't have a clear winner when you do a pairwise comparison. Okay, so here's another preference schedule. Let's look at this smaller preference schedule, right? Let's compare A and B. Okay, so A is preferred over B here and here, but not here, right? So if you're thinking about A, you have 14 plus 12, and that's 26 people. So oh, by the way, here, 14 plus 12 plus 10, that's 26 plus 10, that's 36, okay? And half of 36 is 18. 18, by the way, is exactly half, so that's not a majority, okay? For a majority, you have to have more than half, so this would be 19 is the smallest number to win a majority. You see what I'm talking about? Right? 18 is exactly half. So you have to have at least 19 to form a majority in this smaller preference schedule. Well, 26 is certainly a winner. Okay, so A is over B. Over here, how about A? Is A preferred over C? Well, A is preferred over C here, 14, right? But C is preferred over A in the last two columns, that's 22. Okay, 22 is the majority. So here you can see A is whereas A beats B, C beats A. C is over A. You see that? So A beats B, but C beats the winner of between A and B. So maybe C should be the winner, right? But then when you compare B and C, what happens here? B over C here, 14, but C, it's B is over C here too, right? So B beats C by these 14 votes and 10 votes. That's 24. That is a majority. So, and you can see C is only preferred over B by 12 people. So B beats C. B is over C. All right, you see what's happening here? This is a classic situation where there is no Condorcet winner. A beats B, B beats C, but C beats A. So here's what's happening. A beats B, B beats C, but C beats A. Okay, and this is what happens when you have when you play like the rock paper and scissors, right? I mean, if three people have a rock paper and scissors, nobody wins, right? A beats B, B beats C, and C beats A. So the biggest problem with the Condorcet method is that sometimes you have no winner, and that's a problem, okay? Because if you do an election and you say, well, sorry, nobody wins. And so that is a problem with the Condorcet method. But if there is a Condorcet winner, that person is declared the winner of the election under the Condorcet method. All right. The third method we are going to study, we'll have to, I'll give you a little break after this one, or maybe in the middle of this, but think about this. What is the instant runoff method? This is another pretty important one. Lots of like labor unions seem to like instant runoff method. Runoff means you have a sequence of ways to eliminate people, all right? So here's the rule on the instant runoff method. You ready for this? The candidate with the fewest first place vote is kicked out. I shouldn't say kicked out. Eliminated, that's a little nicer word. Removed, rejected, sent off, voted off of an island, okay? Whatever you want to call it. The candidate with the the candidate with the fewest first place votes is eliminated in that round. And then another table is formed without that candidate that has been eliminated. And again, you look at the new preference table or the preference schedule, and the one with the fewest first place votes is also going to be eliminated. And you're going to keep repeating this until one candidate remains on the ballot, and that person is going to be the winner. You see that? This is a sequence of runoffs. Basically, that's what it is. You get rid of the first person, and then you get rid of somebody else, you get rid of somebody else, and when everybody else is voted out, the one person remaining is going to be the winner. All right, so let's look at it. This is maybe the most complicated one. All right, so I want you to pay attention to this thing again. All right, and I'm going to clean this up a little bit. Okay, so going back to the very first preference schedule we looked at, right? Remember under the plurality method, I asked this question, right? What candidate? Okay, so for each candidate, how many people put that candidate as the first place, choice, right? And I said A, you have 18 people voting A as number 1, and 12 people voting B as number 1, and 10 people voting C as number 1, and so on. E was the first place choice for only 6 people. Remember? Now, E actually won on the Condorcet method, but if you look at the number of first place votes, strictly the number of first place votes, A is the first, B is second, C comes in third, D comes in fourth, and E has the least number of first place ballots, right, the votes, and that's 6, okay? Only 6 people thought that E is going to be the best candidate. So the problem was because E had the least number of first place votes, E gets rejected, right, or kicked off. So E gets eliminated, right? E has only 6 first place votes, so E is sent off, eliminated, kicked out, ejected, rejected, whatever. Okay, so guess what? If you go to the second page, I have the same preference table or the preference schedule, except E has been gone, right? It's as if E never existed. Okay, so with E eliminated, gone, let's count the number of first place votes. What happens? Well, those people who favored E, they sort of lost their first place candidate. That means the second place candidate will move up. Okay, look at what happens. A is still has 18 first place votes. B now has 12, but these 4 people who originally voted for E, now E is no longer running. Okay, I mean, this is very much like what happened, you know, in the nomination process for the presidential candidates, right? I mean, like the Democratic Party had what, I don't know, 12 or 15 candidates, and then pretty soon, you know, this person stopped, this person quit, this person, you know, dropped out, and so what happened is these people who supported the candidate that dropped out are going to join somebody else, right? So these 4 people who voted for E first, well, now E is gone, so now they're going to join B supporters, right? So now B has 12 plus 4. That's 16 first place votes. Did you see what happened here? So B not only has these 12 people who voted for B in the first place, but they have, the 4 people have joined the B camp. And then C, well, C had 10. These 10 people thought C was the best. But now these 2 people, because E is gone, their first choice is gone, are now going to join the C camp. So now we have 12 people supporting C, and D still has 9 people. Hopefully you got that. Okay. And so guess who gets kicked out or eliminated next? Yeah, D with the fewest number of first place votes get kicked out. So D gets removed. All right, let's cross out D from this picture. Okay, now what? In the next round, you have A, B, C left, right? A still has 18 votes. B, well, let's see. B is still, you have 12 people. And then this, is that the B? Well, okay, so B still has this support of this many people. So that's 16, right? C actually gets somebody else because these people, remember, these people thought D was the best, but now D is being eliminated. So the next choice for these 9 people was C. So C actually gets these 9 people added to their camp. So now C has 10, 9, and 2. And that's 21 people now that C has. Ooh, because D got dropped out. C gained quite a big endorsement, right? 9 people joined the C camp, and so this 9, that's the extra that he got, that C didn't get first. So at this point, A has 18 votes, B has 16 votes, C has 21 votes. B is the one with the least number of first place votes. So B gets kicked out. You get that? So B gets removed at this point. Now who is left? A and C, okay? A and C are the only one left, all right? So let's cross out B. So B gets crossed out. B gets crossed out from every single column here. And now it's a duel, the battle between A and C. Who wins? Well, the first place votes, if you look at it, A is over C here. 18 people vote for A. Remember, A was the bottom ranked candidates by everybody else, right? So C is over A here, C is over A here, C is over A, C is over A, C is over A. Sorry, we didn't cross out all the D's here. But the point is, all of these people now, when you have the choice of only A or B, all of these people would vote for C, okay? And that turns out to be 37 if you add up all these numbers. So by the process of elimination, first, remember, E got eliminated, and then D got eliminated, and then B got eliminated, and now A is going to be eliminated. So therefore, by the instant runoff vote, C is the winner, okay? Let me go back and write this, right? Because in the first method, A won. In the second method, E won. Now, in this third method, or under the third method, guess who became the winner? C wins. You see that? I have explained 3 methods so far, And in each time, different person has won. What is going on here? Well, you know that again, the point is that the winner depends on which method you decide to implement. All right. The border count is another method, but let me explain what this is, and then I will let you figure out who wins in the border count, and then we'll come back to the second part of this lecture. But the border count is very simple. It's a point system, okay? Each first place, sorry, let's go from the bottom one. Each fifth place votes gets 1 point, okay? Fourth place gets, so 1 point here, 2 point here, 3 point here, 4 point here, and 5 point, okay? So each 4 point place vote gets 2 points. Each third place vote gets 3, each second place gets 4, and each first place vote is worth 5 points. Okay, let me explain how this works. A has 5 18th place votes, right? How many second place votes does A have? Nothing, okay? How about third place votes worth 3 points each? Nothing, okay? How about fourth place votes? Does A have any fourth place votes? And the answer is no. So how many 2 point ballots does he get? None. And then finally, how many 1 point votes, which is basically fifth place, does A get? And the answer is all of these people. That's 37 of them. Okay, so this is the number of points A would get. You see that? So you have 5 18-point ballots and 37 1-point ballots is what A is going to get. And this adds up to 127. All right, so before you start the next part of this lecture, I want you to calculate the total number of points each of these candidates will get, B, C, D, and E, okay? Do it, and once you are done with this for B, C, D, and E, and that of course, the number of points will determine who the winner is. The person, the candidate with the biggest number of total points is going to be the winner. Find out who wins and come back and watch the rest of this.